Hello again. Let's take a look at section 2.5, which covers quadratic functions. We're going to learn 4 different methods of solving these types of equations. First, we'll do it by factoring. Then we'll use what's called the square root property. Then we'll learn to complete the square and use the square root property. And finally, we'll learn the method that never fails, which is the quadratic formula. Technically, completing the square never fails either. So we'll learn 2 fail-proof methods. That doesn't mean short or easy, but they always work, which is always something to know, since factoring does not always work. And the square root property isn't naturally something that can always be applied in the first few steps. Let me share my screen and we'll get started. We're taking a look right now at section 2.5. When I get started on section 2.5, the first problem out of the box says, solve the quadratic equation x squared minus 6x plus 8. Yeah, I gotta wear the reading glasses. It's getting kind of late and I'm kind of tired. Equal to 0 by factoring. If there is more than one correct answer, enter a comma-separated list. Remember, you have to do what it asks for. If you don't put in the commas, it's going to count it wrong. So let's be sure that we enter it correctly. Now what we want to do is we want to solve this problem by factoring. So first we note that this is problem number 1 and we copy the problem. This protects you in case you copy it wrong. Now let's take a look at factoring x squared minus 6x plus 8. We've learned in a previous method over section 1.5 how to factor using either the guess and check method or by using the AC method. We'll use the AC method here. A here is equal to 1 since it's the coefficient of x squared. B is equal to negative 6 since it's the coefficient of x. And C is equal to 8 since it's the constant. Then we form A times C, which is 1 times 8, which equals 8. Now that we know that we're looking for factors of 8. Let's go ahead and list them out. We have 1 times 8 and 2 times 4. That's pretty much all there is. Now we need to look at the original problem. When we look at the original problem, the last sign in front of the constant is positive. That means that it has the same signs in the binomials when we factor it. It also means that they're the same and they're going to be whatever we see in the middle term. Both signs are going to be negative. This also tells us that we're taking a sum of terms. So in the AC method, we're looking for factors that multiply to give us 8, which we have them here on the side, 1 and 8 and 2 and 4. And that add, since we're taking a sum, since they're the same, keep the s's together, that add up to negative 6. Since the signs are both negative, we know that we can write this as x squared minus 2x minus 4x plus 8 equals 0. We're rewriting the middle term, negative 6x, in terms of the 2 factors we found over here that multiply to give us 8, but add to give us 6. Now we split them into 2 pairs. Usually it works in the order that they're written. If not, you may have to reorder them, and that's okay. Just put 1 with 3 and 2 with 4, or maybe 1 with 4 and 2 with 3. However it works, see if you can get it to factor. How do you know if it factors? You take out the greatest common factor from each pair. That will leave behind a binomial. If the second binomial we get is not identical to the first, the method didn't work, or we've made a mistake. The second one, note the signs are different. It starts with a negative instead of with a positive. That means that we have to take out the negative to get the signs inside the binomial to be the same. So I'm going to factor out the greatest common factor of 4, but with a negative attached. When you factor out the negative, it changes the signs on the inside and becomes x minus 2. Notice that these are identical binomials, so we know it worked. Then we factor out the identical binomial and see what got left behind when we pulled those out. What gets left behind is x minus 4, and this is equal to 0. Now we're going to use what's called the zero factor property. When we're looking at the zero factor property or zero product property, it's called both things. What we're saying is that we have at least two things multiplied together and they're equal to zero. Now, zero is a special number. There aren't any other numbers like zero. It's very special. One is special too, but zero, it's really special. Zero has a property that if you take two numbers and you multiply them together and you get zero, one of those numbers had to be zero. This doesn't work for any other number. I know, you're saying, yeah, it works for 5. It's got to be 5 times 1. No, it doesn't. It can be instead 10 times 1/2. That's also 5. If you want 1, you could do 2 times 1/2 or 3 times 1/3. Both of those will give you 1. The only number that has to be one of the factors in its product is 0. And that's why it's called the zero product property or the zero factor property. It only works for 0. That's why 0's in the name. So we have two factors multiplied together equal to 0. That means one of those has to be 0. We set each one equal to 0 separately, separated by the word or, and then we solve each one individually for the variable x, as we did in a previous video. Adding the 2 to both sides to keep it balanced across the equal gives us one possible solution of x equal 2, and adding 4 across both sides of the equal to keep it balanced gives us another possible solution of x equal 4. You can try both of these in the very original problem that you see up here, and you'll find that they both work to give us the correct answer. Our answers are 2 and 4, and to enter them into web work, we want to put 2, 4. All right, let's take a look at the next problem. It's also a solve the quadratic equation by factoring problem. Again, if there's more than one correct answer, which there often is when we're dealing with quadratics, then you want to enter it into a comma-separated list. Let's take a quick look at this one, and let's do it using the trial and error method. Put your long vertical bar or horizontal bar between the problems and copy down the problem in case you copy it wrong. This time we're going to use the trial and error method, where you use your knowledge of how the trinomial will split up to guide you into what you have. X squared is going to split into x and x. Then we look at the last sign, which is a positive. That doesn't tell me what the signs in the middle are, but it does tell me they're the same. It also tells me that I will be summing the outside and inside product. Then I look at the middle sign, and it tells me, after I've looked at the last sign, it tells me they're both positive. Since they're both the same, I go ahead and write them in. If they were different, I would wait, but that's a personal preference because I hate erasing and I don't like to be wrong. So I leave, if they're different signs, I leave that to the very last step. Now we think about the 2. 2 is a prime number. It only splits up as 1 times 2, other than fractions. We generally are leaving it in integer form, so we're stuck with 1 times 2. We put in a 1 and a 2. Because the coefficient of x squared was 1, it doesn't matter which one is the 1 and which one is the 2. They both get multiplied by 1x. If they were not 1x's and they were like 2x and 1x, it would make a difference. And you have to be careful to balance the size of the center term with the values of the outer and inner product. Now we check it. If I multiply the center together, I get 1x. That's the inner product. If I multiply the outer together, I get 2x. That's the outer product. 1x plus 2x is 3x, which is what I have in the middle, so I know I've done it correctly. This is using what we call the trial and error method, which is really more of an intuition-based method, which is just code for, I've done so many of these problems. I have a good instinct for what they should be because I'm listening to my subconscious, which says, hey, I've seen this one before. Try this. Now that I have this, I look at the two factors, x plus 1 in parentheses and x plus 2 in parentheses. Remember, factors are things that are multiplied together, and there's an understood multiplication between the parentheses. The zero product property tells me that I can solve this by setting each of the factors equal to 0 and solving them separately. That's because when two numbers multiply to give you 0, one of them has to be 0. This tells me that x could be -1 as one possible solution, and x could be -2 as the other possible solution. It didn't say in web work whether they had to be in order or not, so it should take them in either order. Let's try it and see. We got the green check, so the order doesn't matter. That is one nice advantage to web work. Looking at this problem, we have 3x squared plus 4x plus 1. Again, we're going to factor this one and solve it that way. This time we'll use the AC method. We'll kind of alternate methods while we're going through these so that you get some practice and some experience seeing both types. I use both types, to be honest with you. When the numbers get really large and it's hard for me to manage all the different possibilities, then I go to the AC method. Even if there are a lot of factors, it tends to be faster. If the numbers are relatively small, like they are in this one, and prime, then I typically will do the trial and error method or the intuition method. On this one, let's notice that we have a equal 3, coefficient of x squared, b equal 4, coefficient of x, and c equal 1, the constant, c for constant. When we form AC, we get 3 times 1, which equals 3. Now, the only factors of 3 are 3 and 1, so we have no choice. It's got to be 3x and 1x. I could stop right here and go ahead and try the trial and error method. Trying the AC method told me there's only one possibility. So that tells me that I can use a combination of the two methods to solve it. 3x squared will have to split as 3x and x. The constant term is a 1. Now, if it were anything but a 1, it would matter where I put the numbers because one of them is going to be multiplied by 3x and the other one will get multiplied by 1x. Multiplying by 3x will tend to boost the value of the product and give you a larger middle term. Multiplying by 1 tends to keep the product low and will make the inner value for x lower. In our case, we have 1 for the constant, and there's only one way to split it up into integers, and that's 1 times 1. Now look at the last sign, which is positive. They're the same. Now look at the middle. They're both positive. Always apply a check to make sure that you've gotten the correct factorization when you're doing the trial and error or the intuition method. It's not quite as exacting as the AC method. 1x plus 3x does add up to 4x, which is what I have here in the middle, so I know I've done it correctly. The zero product property tells me if I have one factor multiplied by another factor and I get 0, one of them has to be 0. Then I set 3x plus 1 to equal 0, or the other factor, x plus 1 to equal 0. Now I solve them individually. First, I move away the non-variable term to isolate the variable term 3x on the left. Then I divide both sides by 3 in order to isolate x. That tells me that x can equal -1/3 as one possibility. On the other one, I have x equal -1, which I can get by just inspection or by subtracting 1 from both sides. These are my two solutions. Now I enter them into WebWork in a comma-separated list. Number 4 is slightly different. This is using what's called the square root property. In the square root property, you have in the equation something that is squared, and then you have another number, generally speaking. So you might have something squared and maybe two numbers on opposite sides of the equation. The idea is, though, that you only have the one thing squared and no other variable terms. If that's the case, you isolate the thing being squared and move all the numbers to the same side. Let's start problem number 4. Looking at problem number 4, we can see from the beginning that we have already isolated the squared thing. In this case, it is x squared. It's isolated on the left side, and on the right side, we have only a constant number. This is ideal for the square root property. The square root property says if x is being squared, then I can apply the square root to both sides of the equation. However, the side without the variable gets a plus or minus because we don't know anything about x. We don't know if it was positive to start with or negative to start with because it got squared and lost that information. Everything squared is always positive. So now we take the square root of both sides. The side without the variable gets a plus or minus. Now we look at this and we take the square root of 16, which is 4. On the left, the square root of x squared just lifts off the square and we get x, which is equal to plus or minus 4. Another way of writing that is to write x equal 4, x equal -4. These are the solutions to this problem. This is using the square root property. Could you use factoring? Yes, you can. But in order to use factoring, it must equal 0. So to solve this by factoring, you would start over again at the beginning and you would subtract the 16 from both sides of the equation so that you can get 0 on the right-hand side. Then you could note that this is, in fact, the difference of two perfect squares. A difference meaning they're subtracted and each is perfectly squared. When that's the case, remember the pattern becomes a squared minus b squared into a plus b, a minus b. So we take the square root of x squared, which is x, and the square root of 16, which is 4, and then we multiply by the same binomial, but with the opposite sign in the middle. This is set equal to 0. Then we can apply the 0 product property to this. This would give me x plus 4 equals 0 or x minus 4 equals 0. Solving each equation for the variable x, we end up with the same solutions. X equals -4 or x equals 4. You can choose which method you like better. Some students prefer factoring, so that's their preferred method. Some students really like the square root property. When it's applicable, it's fast and easy. I recommend that you have a variety of techniques in case one of them seems like it's going to be more work than the other. Now let's enter our answers and move on to the next problem. In the next problem, we have something a little bit different. This time, the thing that's being squared is not, in fact, just x. It is a binomial that's being squared. But everything else in the equation outside of that square is just a constant. So we're going to apply the square root property again. Looking at this problem, we want to make sure that we first isolate the squared thing. If it is not on one side by itself, then we need to move it to one side to get it alone. That should put everything else on the opposite side of the equation, which should consist of only constants, just numbers. There should not be a variable x outside of the squared thing. If there is, unfortunately, you have to multiply it all out, recombine your like terms, and then start over again. In this case, though, we have x minus 7, the whole quantity being squared, and the square is isolated on the left side. There's nothing added outside of the square and nothing multiplied or divided outside of the square. That means that we can apply the square root property next. I recommend when you're writing up exams that you do exactly what I'm doing here. When you write up problems for the discussion form, you're going to follow the same format. I want you to write out to the side a brief reason for why you're doing each step. You should gear your problems in the discussion forum for the student who has the most trouble understanding, not for me. These are for your classmates. On an exam, doing this helps to prevent you from making careless mistakes. I've seen it over and over in my classes. Even though some of the problems are harder, when students go through this process, they rarely make careless mistakes. So then we apply the square root property to both sides. Remember that the side without the variable gets a plus or a minus. When we take the square root of something squared, it lifts off the square and we get x minus 7 in parentheses. On the right-hand side, we again have square root 16, which is 4. So we get plus or minus 4. Now this is actually two separate equations. And what we need to do now is we need to split it into the two equations. This actually says that x minus 7 could equal 4, or x minus 7 could equal negative 4. Then we solve these problems separately. This would give us plus 7 to keep it balanced, and x equal 11 is one possible solution. The other thing on this side is to add the 7 again, add the 7, but this time, because the right side is negative 4, we get 3. We have two solutions to this problem, 11 and 3. Now, can it be done another way? Yes, it can. It's much longer and much more prone to error. But let me show you what will work if you forget the square root property. One thing you can do is you can take the x minus 7 quantity squared and multiply it out. That means that you're going to take the binomial and write it twice and apply the FOIL method of multiplication of two binomials. The first two, x times x, would give me x squared. The outside, x times negative 7, would give me a negative 7x. The inside, negative 7 times x, will give me another negative 7x, which makes sense. This is the same binomial times itself, so the outer and inner product should be the same, and they'll double. Then I take the last term in each set of parentheses and multiply them. Negative 7 times negative 7 is a positive 49. Now, you might want to go ahead and factor, but that would be wrong. You've got a 16 on the right. Remember, it must equal 0 if you're going to try to solve by factoring. So in order to solve this by factoring, we need to move the 16 to the left to join the other variable terms. As part of that process, I can also add the outside and inside product to get a negative 14x. And then 49 minus 16 would give me 33. Now, these numbers are rather larger. It is true that the coefficient of x squared is 1, which is going to make it simpler, and the signs are the same, and they're both negative. So I'm going to use a combination of the guess and check method or intuition method and the AC method. For the AC method, I have A equals 1, B equals negative 14, and C equals 33. When I'm looking at this, AC is going to be 1 times 33, which is 33. I know that x squared has to split up as x times x. I know that much already. Make sure it's equal to 0 or it will be wrong. It cannot equal any other number. It's the 0 product property. X splits up, or x squared splits up as x and x. And then we look at the signs in the original. This is our new original. The last sign is a positive, which tells me they're the same. This is negative, which then tells me they're both negative. So I've got a negative here and a negative here. Because the coefficient of x squared was 1, I need two numbers that multiply to give me 33, but add, last sign, to give me 14. Let's make a list of the factors of 33. 1 times 33, it's not even, so it's not divisible by 2, and 3 and 11, and I don't need to go any further because I found it, 3 and 11. In fact, there aren't any others. Now I can split up 33 as 3 and 11, and notice that negative 3 times negative 11 would give me 33, and negative 3x and negative 11x would give me negative 14x. This gives me two possible solutions from the 0 product property. Adding 3 to both sides would give me that x equals 3, and adding 11 to both sides would give me that x equals 11. And again, this comes from the 0 product property that says when two factors are multiplied together and they equal 0, one of them has to be 0. Now, which one is easier? Let's look at method 1 again, which is this part right here, which is essentially 1, 2, 3, 4, 5, 6 lines at most. Let's look at the next method, which was multiplying it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that multiplying it out does work, but it is more work. So I recommend that you learn the square root property. It's super handy. In problem number 6, we have an added step to do, which is to go ahead and use the square root property first, or rather not the square root property, to complete the square and then use the square root property. Now, why might we want to do that? Let's take a look at the problem that we have in number 6 and see what would cause us to do this. We have x squared plus 2x minus 5 equals 0. If you try to form AC, you're going to get that a times c is equal to 1 times negative 5, which gives us a negative 5. Now the factors of 5 are 1 and 5, and that's it. The last sign is a minus, which tells us they should subtract. But there's no way that the difference between 1 and 5 is 2. That means that this does not factor. We call such a polynomial a prime polynomial, meaning that it doesn't factor. That doesn't mean it doesn't have solutions. It just means that they're not integer values or rational numbers. It doesn't mean that it doesn't have a solution. So how can we find it? Well, in this particular problem, we have an issue with using the square root property right away. Yes, we have an x squared, but we also have an x term. That's not allowed in the square root property. One thing being squared, and it has to be the variable thing, and everything else has to be a number. Well, that's not the case here. I have a squared variable thing and a variable thing. So what we do is we force this square peg into a round hole by completing a process called completing the square. I have a separate video that just shows this type of problem if you need more practice on it. Let's go through the process. When we're completing the square, what we're going to do is we're going to take the two terms that have the variable in it, and we're going to force it to be a perfect square binomial. That means we're going to force it to be a perfect square trinomial that factors as the product of two binomials. The minus 5 is just going to sort of hang out for a while. So we have x squared plus 2x, and we add the 5 to move it to the other side of the equation. Notice that I left some space here. What we're going to do is we're going to force this to factor as the same binomial twice. In order to do that, we need a new constant term that will allow us to do that. How do we find it? First thing we're going to do is we factor off a if a is anything other than a positive 1. In this case, it's not. But if it were, we would factor it out. The second thing we're going to do is we then look at whatever the middle term becomes after we factor a off. Now, in this case, it's still 2 because a is positive 1. So our b is equal to 2. So we take half of b and we square it. So what is half of b? The first thing I'm going to do is go ahead and write down what half of b is. Half of b is 1, and then I square the half of b. I'm going to take the squared value and add it here. But I've just changed the problem. It's no longer the original problem. So what can I do now that it's out of balance? Well, what I can do is I can add 1 to the opposite side of the equals to keep it balanced. So I add 1 over here as well, and that keeps the equation balanced. I put a +1 on the left and a +1 on the right, so it's still balanced. Now I factor this trinomial. This will always be a perfect square trinomial if you've done it correctly. It will always factor, and the number that you get inside the binomial will be half of the middle term coefficient. So what we end up with is x plus 1 quantity squared, where this one comes from this one. What we have on the right side is 6. If you don't trust me, you're welcome to go ahead and factor this either using the guess and check intuition method or the AC method. It does factor as x plus 1 times x plus 1, which is x plus 1 quantity squared. Now you can see that this is in the form where we can apply the square root property. So the next thing we do is the square root property. We're going to take the square root of both the left and the right side after we've isolated this binomial being squared. On the side without the variable, remember to always put in a plus or minus. You don't know whether that variable started positive or negative, so you don't know anything about the sign of it. So you have to include both possibilities. This time, the number on the right is not a perfect square, so the radical is not going to disappear. These numbers are real. They are on the number line. They're just not rational numbers or integers. Now let's take a look at what we get on the left. We get x plus 1 equal plus or minus the square root of 6. The next thing we need to do is isolate the variable term, which is x. This would subtract 1 from both sides. However, this is an integer, and this is an irrational number, the square root of 6. They're not the same kind of number, so they can't be combined. The best we can do is to write -1 plus or minus the square root of 6. What does this mean? It means there's actually 2 numbers, and the 2 numbers are x equal -1 plus the square root of 6, and x equal -1 minus the square root of 6. These are decimal numbers that appear on the number line, and they have no pattern that repeats, and the decimal goes forever without stopping. These are our 2 solutions. We can enter them in here by using the square root function. So -1 plus SQRT, and then you can open up the parentheses, or you can click on this box and you can put a 6 on the inside. We want a comma separated list, so remember to put a comma in between. If you want, you can copy the first part and paste it. However, when you paste it, Remember that you have to change the sign in the middle, which should be minus the square root of 6. Then you can check your answers. Green checks, gotta love them. Let's take a look at another problem. This is x squared minus 3x minus 1 equal to 0. We can try to factor it, but I can guarantee you it won't factor. AC is a -1, and what we have in the middle is a 3. 1 only has factors of 1 and 1, and the difference of 1 and 1 is 0, not 3. So it does not factor. It does not lend itself to the square root property right away because we have this x term in the center, which is not a part of the square. So we've got to force it to fit that pattern. So we take x squared minus 3x minus 1 equals 0. Again, if a were not a 1, we would factor it off. Now, I keep saying that. If you want examples of that, please watch the other video, and it will show you what to do when a is not a positive 1. In this particular problem, we're going to isolate the variable squared and the variable term, and we're going to move the 1 to the other side of the equation to prepare ourselves for completing the square. To complete the square, when we have the coefficient of x squared as a positive 1 on the left side, then we take the middle term's number coefficient and we write that number down. That becomes our new b, and then we take that number and we find half of it. This number here is the number that's going to go inside the binomial. It will be an x minus 3/2 quantity squared. But we have to figure out what number we have to add here to force it to be that perfect square. The number we add is the 1/2 of b squared. When you square a -3/2, you get a positive 9/4. So we take the 9/4 and we add it on the left side. This creates a perfect square trinomial, which will factor as this binomial squared. Now I've unbalanced the equation again because I added something on one side that I didn't add on the other. So to balance it back out, I can either add it to the other side, or I could have added it and subtracted it, whichever one you want to do. Now we have that this trinomial factors as x minus 3/2 quantity squared, and we need to get a common denominator so that we can add the 1 and the 9/4. Multiply the 1 by 4/4 to get 4/4 plus 9/4, which is equal to 13/4. The next step, of course, would be to apply the square root property. We've isolated a thing with a variable in it, and it's being squared. The other opposite side is just a number, so we apply the square root property. This is going to give us the square root of x minus 3/2 quantity squared, and plus or minus the square root of 13/4. We know that it will simply lift off the square on the left and leave us with x minus 3/2. On the right side, however, we have a fraction under the radical. We can think of division as a form of multiplication, and we know that we can split up radicals among things that are multiplied or divided. Not, however, addition or subtraction. Those don't work. This then becomes plus or minus the square root of 13 divided by the square root of 4. The square root of 4 is 2, which lets us write x minus 3/2 equal plus or minus the square root of 13 divided by 2. Then we can add the 3/2 to both sides to isolate x. Remember that we typically write the rational number first and the number with the radical second. This gives us x equals a positive 3/2 plus or minus the square root of 13 divided by 2. Now, this is actually two numbers. This is x equal 3/2 plus the square root of 13 over 2, which you could also write as a combined fraction, 3 plus the square root of 13 all over 2, and x equal 3/2 minus the square root of 13 over 2, which you can write as a combined fraction with a common denominator, 3 minus the square root of 13 over 2. Let's see if there's a way to enter the answer with a plus or minus. I can't remember, to tell you the truth. So let's do 3 divided by 2. And then let's see if there is a plus or minus. I don't see one there. Others. Nope, not there. Intervals. Nope. Not logarithms or trigonometry or exponents. I think we're out of luck with the plus or minus. What we're going to have to do then is enter them separately. So we have a plus square root, which we can go ahead and click on the template for it. And the square root is of 13, and then move outside of the parentheses to put divided by 2. Then you want to copy everything that you have here, and then you want to paste it in with a minus in the middle. Remember to put a comma between your two problems and to change the sign. Is there another way of solving these? Yes, there is. And this is probably the method that you learn the most often in high school. This is called the quadratic formula. Maybe you didn't learn it in high school, and now's the time that you're going to learn it. The quadratic formula is based on completing the square. So it's essentially the same thing, just in formula form. So they complete the process of turning it into something on which we can apply the square root property. But the quadratic formula has all that work already done and already solved for x. There are two forms that you can memorize the quadratic formula in, and there's even a song for it, but I can't sing well, so I'm not singing it. What is the quadratic formula? When we talk about the quadratic formula, there are two methods. I recommend that whenever you say it in your head, that you always say it the same way, so that it becomes very firmly entrenched in your long-term memory. There are two methods of memorizing it. X equals negative b, or rather I say the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all under the radical, and all divided by 2 times a. Now the a, the b, and the c are the same a, b, and c that we've been using when we've been doing the AC method. Remember that in order to do that, we have to first move any constants and variable terms all to the same side of the equation. So it's equal to 0. Then a is the coefficient of x squared, b is the coefficient of x, and c stands for constant term. There's another way that you can memorize this, which may help you to reduce it when you need to reduce the fraction. And that's to split the two terms in the numerator into two separate fractions. Negative b over 2a plus or minus the square root of b squared minus 4ac, all divided by 2a. Now it's tempting to want to cancel the 2a with the 4a, but this is under a radical, which means it's really not 4a. It's the square root of that after it's been multiplied by 4 and subtracted from b squared. So you cannot reduce anything outside of a square root with something under a square root. Now, when we're looking at this, notice that the square root is going to have a big effect on the kind of answer we get. It's so important that we have a name for it. B squared minus 4ac is called the discriminant because it discriminates between the different kinds of answers we can get. What does it determine? Well, let's suppose that b squared minus 4ac turns out to be the number 0. If the discriminant is 0, then the numerator of this fraction is 0, but the denominator will not be. 0 divided by a number is 0, which means the solution just becomes negative b over 2a. What if instead of being the number 0, it were a perfect square, like 16 or 25? If the number is a positive perfect square, then we're going to get two solutions. This means it's not equal to 0, but we have a positive perfect square. In this case, we get two solutions, which are given by the equation that you see here, or in its alternate form here. What's going to happen is, since it's a perfect square, the square root of it will be an integer value or a rational number. And then when we add it to an integer or rational value and divide by an integer or rational value, we get another integer or rational value, which means that we get two solutions, but they're rational numbers. What if we get a positive number, but it's not a perfect square? Something like 13 or 42. In this case, since it's a positive number, it's not equal to 0. And because it is a positive, then we know the answer is real. It's just going to be irrational. In that case, because it's irrational, the radical is not going to disappear. It's going to stay there. But with the plus or minus, we get two solutions. They'll both be irrational with radicals. There is one other possibility that we haven't included yet, and that is if it's a negative number. If it's a negative number, the number is not found on the real number line. It's found on the complex number line system. It's an imaginary number. In this class, we're primarily going to deal with just negatives, though we could have negatives that are perfect squares and negatives that aren't perfect squares. Negatives that are perfect squares will give us i's, complex numbers in the numerator. Negatives that are not perfect squares will also give us complex numbers in the numerator with an I, but the radical will still be present. So if we have a negative number, we do get two solutions, but they're complex with an I. These are all the possibilities that come out of using the discriminant. Remember, the discriminant is b squared minus 4ac, and it determines the number of solutions that you have and the types of numbers that they are, whether they turn out to be rational numbers, as in the first two possibilities, or irrational in the third possibility, which is still real, or complex with an imaginary part in the fourth possibility. Let's take a look now at problem number 8, which asks us to find the discriminant and then to determine from the discriminant how many solutions there are and of what type they are. For problem number 8, we have 4x squared plus 2x minus 4 equals 0. First, we have to make sure that we have 0 on one side. Then we take the coefficients of the terms. We have a equal to 4 as the coefficient of x squared. We have b equal to 2 as the coefficient of x, and c equal negative 4 as the constant. Then we find the discriminant. Some people use the uppercase letter D for discriminant. This is b squared minus 4ac. If you'll write the formula every time you use it in the homework, you'll probably get it memorized. This becomes 2 squared minus 4, minus is in the formula, times a, which is 4, times c, which is negative 4. I recommend never doing this part in your head. Always write it out. I do. Because I know if I make a sign error here, I change it from being real to being imaginary or vice versa. That's a big mistake. Now I'm going to multiply out these numbers. So I get 4. Then I have a negative times a positive times a negative, which is a positive. 4 times 4 times 4 is 64. This gives me the number 68. This is positive, but it's not a perfect square. "64 is a perfect square, but not 68. That means I'm going to have 2 irrational solutions. They'll be real, they're just irrational numbers with a radical. Let's see how web work is dividing up these possibilities. Our discriminant was 68. And based on the discriminant, I can see that I have 2 real solutions. They're just irrational. Now I can check my answers. Let's skip this problem, which basically does the same thing. Find the discriminant. Based on the discriminant, determine the nature of the solutions. 2 real solutions, 1 real solution, or 2 complex. Over here in our notes, we should notate that both of these possibilities are 2 real solutions. Both rational and irrational numbers are real. They both show up on the number line. The difference between rational and irrational numbers is rational numbers either stop as decimals, like 1/2 is 0.5, or they repeat, like 1/3 equals 0.33333 forever and ever and ever. Irrational numbers never stop and they never repeat. So they're sort of the opposite of the rationals, but they're both real and they're both on the real number line. Now let's use the quadratic formula that we had up here. There are 2 forms that you can use the quadratic formula in. It depends on how good you are at reducing as to which form you want to memorize. If you know that you have trouble reducing fractions, I recommend the second one. If you don't have trouble reducing fractions, I recommend the first one or the second one. It's up to you. Let's take a look now at problem 10. Our problem is 10x squared plus 10x minus 1 equals 0. It is possible that this factors, although I think looking at the numbers that in fact it does not. We could use completing the square and the square root property to solve it. That will always work. Or we can apply the quadratic formula. Let's write down what A, B, and C are. In this case, A equals 10, B equals 10 from the middle term here, and C equals -1. I highly recommend when you do the quadratic formula that you find the discriminant separate from the rest of the quadratic formula. It will make it easier to do because it will be less congested and you'll have less stuff altogether. That's what tends to lead to careless mistakes. So what I mean is go ahead and find the discriminant, b squared minus 4 times ac. This becomes 10 squared minus 4 times 10 times c, which is a -1. Be very careful with the signs on A and C. Notice that it is solved for 0. It has to be in that form before we find A, B, and C. Now we can multiply out the numbers and we get 100. Then we have a -4 times a +10 times a -1. 2 negatives make a positive, and 4 times 10 times 1 is 40. This gives me a discriminant of 140. which is not a perfect square. So I know I have two real solutions. They both happen to be irrational. How can I use this in quadratic formula? Let's write the quadratic formula down. The opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. We'll use this form first. The opposite of b means whatever number you got here, take the opposite sign. So since that was 10, we'll use negative 10 plus or minus. I know what the discriminant is. I've already found it. It's 140. So I put 140 under the radical. Then I divide by 2 times a. A was also 10 because it was the coefficient of x squared. Now we can multiply out the denominator. I recommend that you go ahead and split it up. We're also going to take a look at the radical. I need to break it down and to see if I have any paired factors. I know I can break it into 10 times 14, and 10 becomes 2 times 5, and 14 becomes 2 times 7. That gives me one pair of 2s. That will give me a 2 on the outside. That means the 5 and 7, of which I only have one each, get left behind. 5 times 7 is 35. Here's the difficult part of this method. Some students want to reduce the 10 over 20 and forget that the 2 is also being divided by the 20. I highly recommend that you split it into two fractions. This is negative 10 over 20 plus or minus 2 square root of 35 divided by 20. Both terms in the numerator are divided by 20. Now individually reduce the parts that are outside of the radical. 10 divided by 20 will give me 1/2. 2 divided by 20 would give me 1/10. And that becomes our solution. That's actually two numbers. That's 1/2 plus the square root of 35 divided by 10. That's a 1. It looks kind of weird right there, but it is a 1. And 1/2 minus the square root of 35 divided by 10. Let's take a look at another problem. We have this one, that one, and then a different type of problem. Let's go ahead and look at problem 11. Problem 11 tells me to solve by using the quadratic formula. I'm going to write the equation and make sure that it is equal to 0 before I find a, b, and c. A is 1, b is 1, c is negative 4. Coefficients of x squared, x, and the constant. Then I'm going to find the discriminant because I don't like writing everything all at once in the quadratic formula. I've seen too many students make many mistakes there. The discriminant is going to be b squared minus 4 times a times c. This is going to be 1 squared minus 4 times 1 times negative 4. This gives me 1 plus 16, which is 17. Again, not a perfect square, so I can't get rid of the radicals, but they're irrational numbers, which are real, two real solutions. Now I'm going to write the quadratic formula in the other form, and you can see which one you like better. The variable is equal to the opposite of b divided by 2a plus or minus the discriminant b squared minus 4ac all divided by 2a on the outside. Then I can say that the opposite of b is a negative 1, and dividing by 2 times a, which is also 1, will give me 2. Then the discriminant was 17, which I can fill in directly. And since the denominator of the two fractions are identical, I can write 2. It's relatively straightforward in this format and less prone to error. Over the years, I've kind of changed my point of view on this. I used to always use the first form of the quadratic formula, but I've seen how many careless mistakes it can lead to by having one combined fraction. I'm shifting now. I think actually having two fractions is better. This again gives you two different numbers, -1/2 plus the square root of 17 divided by 2, and -1/2 minus the square root of 17 divided by 2. Notice that the sign of the 1/2 does not change. It's always the opposite of b over 2a. Let's talk for a minute about problem 13. In problem 13, we have an applied problem. A falling object travels a distance given by the formula d equals 2t plus 5t squared, where d is measured in feet and t is measured in seconds. How many seconds will it take for the object to travel 57 feet? Well, that's our distance, d. Round the answer to 4 decimal places. What we're going to do in this problem is we're going to write down the equation and talk through what you would do, and then I'll let you work on it on your own at home. When we have this equation, we have d equals 2t plus 5t squared. Then they tell us that we're to find how many seconds, which is t, for the object to travel 57 feet, which is d. What we need to do is replace the d in the original problem with the 57 feet. We can leave the feet off for now and just understand that that's what it represents. This gives us the equation 57 equal 2t plus 5t squared. I know you're very tempted to start pulling out a, b, and c, but you can't. First off, you've got a 57 on the wrong side. It must equal 0. And second, these aren't in order. It should be 5t squared first and then 2t. So let's move the 57 to the right and reorder things. This, written in the correct order, would be 5t squared plus 2t, since there's no negative out front, minus 57. Now the equals would be on the left, but if it bothers you over there, it's okay to swing it around. Things that are equal to each other are balanced, so it doesn't matter which is written on which side. Now that we have this, we can pull off our a, which is 5, our b, which is 2, and our c, which is negative 57. Then you can use the quadratic formula, or if you want, you can complete the square and use the square root property to solve this problem. I'll leave it to you to decide, but I think I would probably recommend the quadratic formula. We have one last problem, which I want to talk about how to set up. Let's take a look at it now. In problem number 14, we have a picture up here at the top, which shows a garden on the inside or a vacant lot, which is in green. It's 15 feet wide and 12 feet high or long. This vacant lot is being converted into a community garden. The garden and a walkway around its perimeter have an area of 550 square feet. Find the width of the walkway if the garden measures 12 feet wide by 15 feet long. Okay, well, the gray is the walkway or sidewalk around the vacant lot. So let me go back to the beginning and start writing down information. The first thing I want to do is take a picture of what I have here so that I can label things on my picture. I'm going to take a picture of the plot as it appears, and then I will probably label it. When I'm looking at this picture, I can see that I've got 15 feet this direction and 12 feet this direction for just the green space, but that does not include the sidewalk. Let's read the words. A vacant lot, got it, is being converted, got it, into a community garden. Got it. Notice that I'm breaking the words apart into the parts of speech: subject phrase, verb phrase, prepositional phrase, subordinate clauses, conjunctions, punctuation marks. For those of you who didn't excel at English, go about every 2 to 3 words and stop at a natural breaking point and ask yourself, do I need to write anything down on my picture or write anything down on my paper? For all of that information, there's nothing to write down other than to draw the picture if you didn't take a copy of it. Now the next sentence: the garden, got it, and a walkway, okay, around its perimeter, got it, have an area of 550 square feet. That I need to write down because it's a number. Area of lot and walkway equals 550 square feet, or feet squared. Okay, well, I'll have to think about that. I may have to write down more for that. What about the last sentence? Find the width of the walkway. Wait. Find the width of the wall. Well, how wide is the, what's labeled on the picture that the width of the walkway is X. I like to put find X equals something with a blank so that I know when I have the blank filled in, I'm done. Then it says, if the garden, got it, measures, got it, 12 feet wide by 15 feet long. That's already labeled on this part. Now, how can I express the area of the lot and the walkway? That would be this area right here, this length, and that width. Well, what are those lengths and widths? From here to here on the green, it's 15, but I've got an X width on the left and an X width on the right. So the area that gives me 550 square feet, oops, I keep erasing while I'm writing, has got to be 15 feet plus 2 X's. That's the width of the new walkway plus the lot. What's the length of it if I go this way? Well, it's got 2 walkways, which is X here and X here, or 2X, and 12 feet this way. So then I need to multiply by 12 plus 2X. Okay, I think I'm starting to see an equation emerge. Area is length times width. And that is the formula that I use to write down this expression that you see here. What I have is 550 is equal to 15 plus 2X times 12 plus 2X. Now, how are we going to solve this? It's not a squared thing, so I can't use the square root property. I could multiply this out, and then I could move the 550, and then I would have a choice between completing the square, factoring, or the quadratic formula. Let's go ahead and do that now. All of those methods require one side of the equation to be 0. So we're going to use FOIL to multiply out the right-hand side, and then after that, we'll move the 550. 15 times 12, I don't know what 15 times 12 would be. Let's see. 180. That's first times first. The outer product is 15 times 2X, which would give me 30X. The inside product is 2X times 12, which would give me 24X. Then the 2X times the 2X, the last, would give me 4X squared, and it's still equal to 550. Let's add the like terms that are already on the right side and reorder it with the square going first. This gives me 4X squared. These two middle terms combine to give me 54X. And then I have the plus 180, and it's still equal to 550. I still can't solve it by factoring or completing the square or by doing the quadratic formula until I get it equal to 0. So the last thing I'm going to do is subtract 550 from both sides. This gives me a 0 here. And then I have 4x squared plus 54x minus, well, what would that give us? 370 negative. Now we have a choice. Notice that all three of these terms are divisible by at least 2. In fact, they're divisible by 2, but not by 4. One thing I can do to make this easier to solve is to go ahead and divide all the terms by 2. It does change the equation, but it does not change the solutions because I applied the same process to both sides of the equation and because I'm not dividing by the variable. Don't divide by the variable. It's a bad idea. This gives me each term divided by 2. This is going to give me 0 still. This becomes 2x squared plus 27x. And the last part becomes 185. Now I have a choice. I can do the AC method for factoring. I can try to complete the square, or I can use the quadratic formula. None of them look particularly inviting, but I think on this one, because the numbers are relatively large in these two terms, that I'm probably better off with the quadratic formula. You choose the method you think is the best for you and apply that method. In the next video, we'll be talking about the next section, which is section 2.6.